This evening we're kicking off an entire series of talks devoted to better understanding what Thoreau called a landscape's most beautiful and expressive feature. And there are a few people we need to thank for that. First, I'd like to thank Sandy Bain for helping to identify and recruit our Cape Cod-based speakers. We have incredible resources of talent and expertise here on Cape Cod. Turns out all we need to do is ask. So I'd like to thank those speakers for their generosity in donating their time and knowledge. I'd like to thank Jane Crowley and the Health Department for bringing the town's expert consultant out here in June to get specific about how our ponds are doing. I'd like to thank the Turn Foundation for its financial support in making possible the appearance of our featured speaker, Kurt Steger, mid-June, and finally Nancy and Pete Eisenbarth for putting them up while they're out here, Kurt and his wife. Tom Cambereri is the very recently retired Director of Water Resources at the Cape Cod Commission. If we've got anything, we've got water. And Tom has spent his career figuring out how water works, what we've done to it, and how to fix it. He got to start with a master's degree at UMass Amherst, specializing in hydrogeology. He's done water supply assessments out here and helped sort out the messes at Joint Base Cape Cod and the county's Fire Training Academy, if you remember all the news about those. But Tom can also help those of us who know next to nothing with our pond and water ABCs, and that's what he's agreed to do for us today. So Tom Cambereri.
Well, thank you, Jim, for that introduction. It's a pleasure to be here. As most of your speakers would tell you, it's really nice to be here to talk about ponds and spring. Have you heard the spring peepers out there? Yeah, this time has come, as spring is sprung, and we're moving forward into some good weather to enjoy these beautiful resources. So I'm recently retired. I've had the opportunity to work all around the Cape with a lot of the tried and true folks from out here in Eastham, certainly Sandy Bain on ponds, but Sheila Vanderhoff, Herb Whitlock, the founder of APCC back in the 80s, and just a whole wealth of it was a great opportunity to work with some wonderful people on a lot of different projects. So I'm pleased to be here. And so today we're going to talk about ponds, and Jim opened it up for me to say ponds and how they work. And geez, I'm usually, we've got a whole pond program, and we talk about the very details of ponds, how they stratify, the epilimnion, the hypolimnion, the phosphorus loading, and all that. I'm not going to go into all that detail on that. I'm going to talk about how ponds work and my experiences with ponds and how they interact with the aquifer, and by being exposed to that, to those types of projects or case studies that we've learned from those, and can apply them to the issues that we have. So I don't so much look at ponds today as the resource, the sensitive receptor of our focus, but I'm looking at ponds as to how they interact in the aquifer and with the other resources around us. So a little bit of a different twist, and I guess that's what being retired allows you to do, is to think outside the box. So instead of telling you about the 208 plan and things like that, I'll be talking to you about ponds. So I'm going to talk about some of the geology, groundwater, ponds, the pond case studies, and we'll just open it up for questions. So how do ponds, how did they get here? How did they form? And so we go back and we hark back to the Laurentide ice sheet over 20,000 years ago. And this was the extent of the ice sheet. And I had a great opportunity in UMass to work with one of the leaders in glacial geology, Joe Hartshorn, who was studying geology in Harvard University. And war broke out in Europe, and he joined the RAF in 1939 and flew planes, supply planes, from Canada over the Arctic, or fringing across it, and really became interested in the ice and the glaciers and how they worked. And so I had a great opportunity to work with him and learn about how it affected, how it gave us what we live on here, Cape Cod. So, geez, look at that ice sheet. It's very thick, 3,000 meters. I think there's a thing there. There it is, 3,000 meters. That's almost 2 miles. And then here's our little Cape Cod thing over here, 1,000 meters. So maybe about, what is that, over 2,000 feet? Over 2,000 feet of ice thickness, right where we are. And you can imagine the power of that moving ice, live ice, moving debris and moving rock, gravel, pebbles, boulders, Doan's Rock, if you've ever seen it down there. So here we go with the closer look at our ice sheet. 15,000 years ago, its maximum extent coming down through the islands, and then when it starts to retreat, about 15,000 years ago, into these lobes, the different lobes of ice. And so I would draw our attention right here between this crevice here, the South Channel Lobe and the Cape Cod Bay Lobe. And so what happened here, and how did this affect what we have here in Eastham? Well, so we look at deposition from glacial ice sheets, and then we have these very regular types of depositional environments. We have the lake bottom sets from which the deltas come in, and so all the ice is bringing all the debris up, and it comes down and it falls into proglacial lakes. So you have lake bottom deposits, and then the foreset beds of the deltas, where it gets a little bit more coarse, and then the topset beds are really coarse. So right about where in Eastham, we'll think about these bottom set beds and the lacustrine deposits, the lake bed deposits. So here I am talking about Glacial Lake Cape Cod Bay. This is what that left. And if we go to the Mid-Cape area, just to see another view of this, here's this lake bottom deposits. Why was there a lake? Well, the ice didn't just all melt all at once. It melted, it re-advanced, it melted, it re-advanced. So we had these berms set up further out. You could see these came deposits in Barnstable, and this locked in a lake. And so we have the bottom set beds and the foreset beds and the very coarse material, and then the moraine. So again, we'll be thinking about this situation here. So we had these two lobes coming back, and as they came back, this was one of the first areas in that interglacial triangle where the glacial plain was deposited. And it's kind of interesting when you think of ice and how thick it was as it receded. Each deposition has a different level. So we have the Wellfleet Plain, which was higher, and then we had the Truro Plain, which is lower, except for this little piece in here. This is the Highland, where Highland Light is. It's the highest piece of glacial deposition on the Outer Cape. And so 1, 2, this is lower than the Wellfleet Plain, and then out here is the Eastham Plain deposit. And so it's a little further away from the source, and it gets into some of those lake bottom deposit areas that were again overridden by sand and gravel. Well, how do we know that? Well, geez, if we look at a boring that's right here, it's right where the bike path meets, what is it, the Nauset Road there. Here is this boring that went in 500 feet down, and so we go through these coarse topset deposits here, and then we get into this glacial lake bed, lacustrine deposits, all clays, and that, and then various back and forths of clay, and then maybe some sand during a readvance, and then bedrock. So what we know and what we see on the ground and what we see in the borings, we put together this picture of glacial geology. And so we get into we get into how do kettle hole ponds form here on Cape Cod. And as the ice receded, there was pieces of dead ice that were left behind, and they were subsequently buried, and when the ice moved out and melted, it left these depressions. And here's a very cartoonish scenario from the retreating glacier with the ice blocks being buried, subsequently being buried, and then as it melted out, it had these depressions, kettle holes. And then this is really interesting. When the ice left, where was sea level? Well, sea level was out about another 140 feet out past the island. So sea level began to rise. And sea level rose, I think some of the research shows about 8,000 to 6,000 years ago. The water table, the sediments held the rain, and our water table rose as the sea level came back, and the fresh water was on top of it. And so what we're left with is the deep kettle holes with ponds. We've got dry kettle holes, and we have vernal pools as well. So we were talking about groundwater and the groundwater rising. And so this is a map of the water table in Eastham. It's part of the sole source aquifer. It's part of the, we call it the Nauset lens, because there's 6 separate lenses, and the sole source aquifer is our sole source of drinking water. It provides fresh water to the ponds, and it ultimately discharges to the surrounding marine waters. And why is that? Well, this is the high area, and it's one of the reasons I went into geology and hydrogeology, because it's very easy to understand that water would flow downhill from areas of high elevation to low elevation. So we have these high areas of 16 feet above mean sea level is the top of the lens here, and it goes down to sea level. And some of the other features we see here are the Nauset Marsh, Salt Pond, which is a salt pond, but formed just like the other ponds, where the water table contours bend around and groundwater flow converges on this salt pond. And here's our cross-section of the lens, pretty much in this area. And the water table is replenished solely by precipitation. It's not just a stagnant pool of water under there. It's a dynamic lens. It is always in motion between recharge from rainfall and precipitation to discharge to the surrounding marine waters. I think there was just a letter to the editor in the Cape Cod Times today or yesterday, and was talking about how, if we're not careful, someplace out here could get contaminated by something at the MMR or something like that. But that's the single pot with a straw theory. This theory, if you know how groundwater flows, you would say this is a separate lens, and this lens, although it's part of the Cape Cod aquifer, is not connected to the rest of the Cape here or even Wellfleet up there. So we need to figure out what is happening here in the Eastham Nauset lens. What else can we say about this? It's replenished by rainfall. And I talked about how it follows these lines. And our watersheds on Cape Cod are defined by the flow from the groundwater lens. So groundwater flows perpendicular to these contours. So here we have the watershed to Nauset Marsh, to the Atlantic Ocean, to Cape Cod Bay. And this whole area here is the pond recharge areas. And this was this was developed by the USGS with a groundwater flow model by which we've taken a lot of information from it and we've modified them a little bit. So it might look a little bit different to you, but this is the modeled output of the pond shadow area. So water flows into these ponds and then back out. And it was the USGS study came up with a percentage of groundwater flow that flows through ponds on the Cape is about 40% of the water, in the upper mid-Cape areas. So it means that water will discharge into a pond and flow out of the pond, and that will account for 40% of the water in the lens. So here we are, the Cape Cod Pond, a kettle hole, and it's a window on the aquifer. And a window is kind of interesting. What he says, yeah, it's where we can see the water table, but it's also a geologic term. And when we had these great giant thrusts, rock thrust faults, and there'd be holes in them. And you could see, through the Devonian sediments, you could see part of the Ordovician below it because there's a little piece of it pulled out, and that was called a window. So we said, well, geez, that's just like this. This is a geologic term. There's a window on the aquifer. So this is how our ponds function with groundwater flow on the upgradient side. It takes it in, and then it becomes the focus of a source of water that discharges down gradient. There's no typically inlets to it or surface outlets. And so when we study ponds, we need to know things like what's the water budget? How much water is getting into that pond? And we sum up precipitation. We subtract evapotranspiration. We look at groundwater inflow, and that's probably one of the most difficult things to estimate, because how do you measure that groundwater flow? And there's lots of different tools that we have as hydrologists, but you don't have an actual measurement any one place to get the whole flow into it. So there's some uncertainty about that, but we've gotten pretty good with it. So if we know the flow into the pond, then we can also estimate the outside. And then we can come up with, well, how much time does water spend in this pond? And that's very important for what you'll hear about in subsequent talks about phosphorus loading and nutrient cycling, and how long is the residence time in a pond, and what is the inputs from the land use that comes into this, the fertilizers, the septic system, phosphorus, the road runoff. These are all things that I think will be covered in the next several talks. But you sum those up, and then you figure out what the budget is, how much is that in there, and how long does it stay in there. And that comes up with your eutrophic index to figure out how healthy this pond is. So that's just my snippet of that issue is that these ponds do have many sources of phosphorus that we're responsible for. But remember, these ponds have been around for over 8,000 years, and biologists have gone down and taken sediment samples out of these things and have found pollen cells in the organic matter here that dates back several thousand years ago. So these ponds, like any other depression, when you think about it, are collectors, kind of like your belly button. And and you have a lot of things in there. And so the management of how to deal, because that organic matter is also another source. And many pond studies that we've done across the Cape really start to focus on that organic matter that is sitting there, that's being added to year after year. So that becomes part of the issue that you'll be talking about, is how do you deal with that organic matter, whether alum treatment, the new oxygen bubbles, or whether you dredge, or whether you put different wind aerators on it. And that's all what it's dealing with. So I'm going to move on from there, from that topic, and leave the rest of that for later. Just to say that, ponds are important. I was proud to work with, through the Cape Cod Commission with my staff and Ed Eichner, who you may know, and others, where we put together the Cape Cod Pond Atlas, and just some of the figures here, that we have a lot of ponds, but a lot of these ponds are less than an acre, 400 some odd. There's 420 named ponds, and 21 of the ponds make up 48% of the freshwater surface area. So of that 10,000 acres of ponds, 21 of them across the Cape make up half of that. So some of those big ponds, Mashpee, Wakeby, Waquaket, Long Pond, Upper Mill, Lower Mill, some big ponds here. So this is the Seki Dip-In. We started our pond projects back in the year 2000 with a grant, and we got real excited. We had a great room full of people, maybe twice to three times as many people in this room today, that said, "Geez, ponds! We want to know more about ponds." So it started a whole project called the PALS program, and we got into this whole thing of, well, everybody needs a Seki disc. So me and my staff, we figured out a way to make them, and we made them there at the Fire Training Academy, and we put them in this truck to dry, and we couldn't resist this picture. And we didn't really go around and deliver them. So the pond program's gone on for a number of years, and of the 229 ponds that we have data for, this is kind of how it shakes out, that 20% are eutrophic, meaning they're not very healthy at all. Mesotrophic, 29%, means they're in an in-between stage. They still function for potentially swimming and some fishing, but they've got some problems with them. And then oligotrophic, they're in fine shape. They're just very clear, clean water, cold water, 20%. And we've got a lot of, we don't really have enough data to interpret the ponds. And that's only of the ones that we've sampled. And let's talk about the PALS participation. This is the group that we have that samples ponds through the years. So we started this in 2001. And we had all towns participating. We had over 400 samples, over 200 ponds. And now we're kind of down to 2015-16. Well, we're sampling about 100 ponds with about 200 samples. And this is kind of an attrition, I think, different priorities or focuses and things like that happen. And I think one of the key things that any community needs is the volunteer stewards, and that's what the PALS program is. It's Pond and Lake Stewards, and that helps the town provide the resources to supplement the volunteer efforts, so that ponds sample information can be generated, so we know what their health is over time, and we can take action. Here's your ponds in Eastham. 23 ponds, 5 of them are greater than 10 acres, and they're I know that they've been studied. We've had we had Cape Cod Commission study that was done in the turn of the early part of the decade. and have your own consultant who's going to be coming to talk to you about them. So I'll leave that and the stories about how these ponds are doing with them. And I want to get on to some of the other issues that are going on. One is the water table. They are part of the groundwater system. So as the water table fluctuates, so do these ponds. Has anybody noticed how much beach area they have around your pond these days? A lot? No, not a lot. So, here we are here. This is the last measurement that was taken in our monitoring well in Eastham that we measure. I say we again, it's the Cape Cod Commission. I measured it, I started here. So basically on monthly measurements. And so we are at a very high period of water table right now. We're over, if you took all the measurements, and you would say 90% of them were lower. So we're at the 90th percentile. We're really high. As a matter of fact, we had record high in last year going into April, May. And so we're still moving up here. I think this latest reading is right about here. But over this period of time, you can see some of the ups and downs. You can see the drought of the 81, the drought of 91 about, the early part of this, the century here. And we also see the highs as well. So these, when people say, well, geez, what's happening to our pond? We need to manage this. We need to do something. We need to let a board out. If they happen to have a pond that has a drain on it. And I've been involved with a lot of different places, like Wequacket. They want to take the boards out and drain the pond. Well, you can't drain the pond because it's part of the groundwater system. You would have to drain the aquifer to get rid of all the water. So these are some of the conversations that we've had. And then this is that well also. So this is the average condition, just to show you on that well. So here we are in March, February, March. I think the March reading was just taken, and it was like up in here. So here's the average condition. This is the 90th percentile. And, if it was above, it would be a record high, like it was last April. It was a record high. Incredible. Over my lifetime, we saw record highs everywhere. So we don't know where this is going. It's been somewhat dry. We haven't had a series of 3 nor'easters like we did that left us with this high water level. So I don't think it's going to crest right where it is, but it is very high. And so what does that mean for our ponds? What does it mean for our aquifer, where we live? So this is the depth to water map. And so here's the high Wellfleet Plain deposit. Here's the real high Truro deposit. Here's the Highland deposit up here. This is the highest piece of land here. And here we are in Eastham with lower elevations, being that it was part of that later deposition. And there's kind of interesting areas in through here. There's Salt Pond. But there's this collapse valley in through here, which are lower water levels. And I just want to take us on a trip to that. This is the townland that's located over here. And this collapse valley is filled with vernal pools in these little areas. So these ponds are just about below the water table. And we did a study in the 90s on this area, and we instrumented it, and we took readings, and we did measurements in the depth of them, and because we wanted to know how these ponds, because these are ponds, they're vernal pools, but they're ponds, and some of them are year-round. But so we wanted to study them. And I just wanted to just take a break on this. I had a fun project we did, and I am going to go here. And let's hope this works. So this is I'm not going to spend a lot of time on the explanation, but this is animation that we put together of the changes in the water table as we looked at precipitation every quarter and how much was coming down and how the vernal pools changed. So here we go. We did this back in the late 90s, and so I haven't had a chance to show this to anybody since then. So I said, this is it. So here we go. So we're zooming in. There's your vernal pools. And we're going to start in 82. And what you'll see is the cyclical disappearing, enlarging with high water tables, and then the vernal pools disappearing or becoming smaller during the summer and fall periods. So spring and early summer, it's the highest, and then summer, fall, it goes to its lowest. So when it turns around to about 1990, the 91 during that period of time was really the low part. And so you'll see these ponds, we're at 86 now, that they'll dry up and, for the most part. And so they're pretty high, up in 87, and they're going along. It's a little long, but was my time up?
No such luck.
Okay. Okay. So here we go, 1990. All right, there they go. Oh my God, where are they? They're just about gone, and yeah, they're just about gone. And when we did this study, and then they came back. So everything is cyclical here. And if you think you're at a point where you need to take a step to manage something, sometimes you let this cycle run through. I'm not sure if I said that right, but I just wanted to share that with you as part of our pond work. Okay, so we've seen that enough. Okay, so here again is our what we know about these ponds and how they work with groundwater flow. And this is the pond, the bottom sediments, and there's kind of a lower extent of inflow. And this is the big game that we play as hydrologists and limnologists to figure out what the budget is. How much of this groundwater is going in? Is it just this much, or is it in this picture showing about that much? Or if the pond was deeper, how much more of this would go up? And at what point does the flow diverge from going up into the pond to going under the pond? And then this also shows how much of the pond water is then again recharged back into the aquifer, and what is that? And they've done some interesting studies with oxygen isotopes and that, and with lots of wells going down, and they could tell, as this water sits here and how it changes its isotopic value, how it's different from the groundwater beneath it. So there are some exquisite types of tools that one could use. We talked about underflow, and I don't want to get into this too much, but this is the whole nitrogen issue here. And these ponds do function because when they have this residence time, they basically attenuate nitrogen, and how they do that is up for biological uptake, but also as that groundwater flows through that pond sediment groundwater interface. There's kind of a micro geochemical area there that's anaerobic, and it takes the nitrogen out. So when we this was important to use the ponds in the MEP studies that we did. The MEPs for nitrogen loading, the 208 plan, when dealing with eutrophication. And our research on ponds was really useful because we knew how much to say that was being attenuated. So if you had housing up in here, it would come in at a certain load, and let's call it 3,000 kilograms, and it would be attenuated by 50%. And it would be attenuated again, and it would be attenuated, and then so this amount here, would be almost down to 50 kilograms at the end. So the attenuation that ponds play in our aquifer system and for the studies of nitrogen loading within these large coastal watersheds. LaQuoit Bay has a coastal watershed that goes 5 miles up to and through the MMR with some huge ponds in them. And quite a lot of nitrogen does get attenuated in those. So let's get back to Eastham here. This is another study by the U.S. Geological Survey. They took all the homes and they loaded it, all the wastewater load and the nitrogen into the groundwater model. And so these areas from cold to hot show nitrogen in the groundwater and where it flows. And one of the key things that you can see here is the load from the old landfill and the sewage, not the sewage, but the septic lagoons and that are comes down and kind of focuses into the Minister's Pond, or that's the way that this was modeled. There's still some debate about exactly how this works and to what extent it does. But the MEP study shows for Salt Pond, the landfill is a fairly significant source of nitrogen, but it does get attenuated in Minister's Pond. And then here's the shadow here of nitrogen that's taken up. So I guess good thing for ponds that they're phosphorus limited, not nitrogen limited. So typically the large nitrogen loads wouldn't be harmful for their health, but that the so instead of phosphorus, it's nitrogen coming down. Yeah.
Yeah, people may not understand the
Yes, yes. It's, I could spend the whole rest of the night talking about that. And just to say that saltwater systems are sensitive to small amounts of nitrogen coming into them. So they're nitrogen sensitive. And freshwater ponds are phosphorus limited. So they're sensitive to small amounts of phosphorus coming into them. So if you have, in this case, a pond that's getting a lot of nitrogen, it can handle the nitrogen, but it can't handle the phosphorus. And when we talk about phosphorus migration in the aquifer, it doesn't move hardly at all in relation to nitrogen. So nitrogen is a fast mover. It doesn't attenuate, and it doesn't attenuate in the aquifer. But if it daylights into a pond, there's a opportunity for attenuation of that nitrogen, and in most cases, it's not harmful to the pond. There are some people that will say some of the more pristine ponds are nitrogen sensitive, some of the ones in the park. So we're still kind of debating that back and forth as well. But I guess the point of this graph is to show how ponds are interacting with the land uses and the groundwater around us, and in a very pragmatic sense that it's reducing nitrogen that otherwise would need to be sewered. So Salt Pond is one of those watersheds where 100% of the nitrogen needs to be taken out. But if 30% of this nitrogen and the area over in Brackett Road and all that in the area in here, if 30% of that is reduced naturally by this pond set, that could be looked at as a good thing. And when you get into looking at the cost of nitrogen removal and for conventional wastewater systems. So that's a whole nother talk as well, is what the technological solutions are for reducing nitrogen. Well, let's focus on ponds. Here's another pond set that we worked with in Barnstable. This is the Mystic, Middle Pond, and Hamlin Pond. It's called the Indian Ponds. And we did studies on these. These are showing bathymetry. So the ponds are 42 feet, 30 feet, 50 feet deep. And in this cross section shows kind of what we interpreted to be going on with groundwater flow and the nitrogen coming into it from land use, going into Mystic Lake, coming out of Mystic Lake into Middle Pond, and then from Middle Pond into Hamlin Pond, and from Hamlin Pond down gradient. So down this area would be the attenuated load. And the attenuation that happens is 87% in Mystic Lake, 52% in Middle Pond, and 40% in Hamlin Pond. And we did some pretty detailed studies on these ponds to look at the not only the groundwater flow but the phosphorus loading and the residence time and the attenuation values. Here's another pond situation that I wanted to share with you, some of the work that I was exposed to on the MMR. Here's Johns Pond and Ashumet Pond, fairly big ponds down in the Falmouth, Mashpee area. A little bit of Sandwich as well. And so this is a contamination plume. It's called SD5 plume. Jeez, back in the 90s we developed this. And so this plume of solvents came down, and it was mapped laboriously with wells and sampling and all that, and it looked to be coming into Johns Pond. These are the groundwater contours here as well. So from 20, 35, 40. So the groundwater flows perpendicular to these lines, and you can see the lines. And this is the flow, into the ponds. This would be again into Ashumet Pond, into Johns Pond, and out. And over here, it comes across, glances across Ashumet into Johns Pond. And this is what it looks like in the cross section. It's a huge aquifer here. Johns Pond is about that deep, about 60 some odd feet deep. And the storm drain is quite a distance up gradient. That is over 2 miles up there. So it's come down through the aquifer 2 miles to kind of come along and discharge into Johns Pond. And so they did a lot more study on this, and they did these transects where they actually put in probes into the sediment and sampled for the volatile organic compounds in this huge pond. And they found this is where that groundwater comes in with the storm drain. And so it's very interesting, and doing this type of work is really what helps us understand and be able to better calculate and estimate how much flow is coming into these ponds in total. Not to mention just using this as a lesson so that we have this disastrous tracer experiment that was put into the ground for us in the 50s to give us this information about how groundwater works and how it discharges into this pond. Here's another kind of case study that I was involved with. This is at the Fire Training Academy in Barnstable. This is Independence Drive. If you come in the back way, you're coming through. This is the Cape Cod Potato Chips Company. They had an issue with their, they were doing lab analysis to figure out if there was any water in their oil, and they just threw it. So over a period of time, I think it was like 2 gallons of chloroform. It ended up in a huge plume that closed down a supply well here, and then came across, and then just as we were cleaning up this petroleum plume, I said, well, this needed to be cleaned up because it was also heading towards these other wells. So how does this, it's kind of interesting. So here we have Flint Rock Pond here. The groundwater flow is this way, and all the contamination at the site is going that way. It's not going into the pond, it's going that way. And then this chloroform plume is coming down, and this aquifer is only 35 feet deep, but it is coming across and does not daylight into the pond and just continues on. So when we think about the recharge area for Flint Rock Pond, it's got to be very shallow. And that makes a lot of sense because it's about, 8 feet deep there. So this helps us understand how to calculate recharge areas. And if we can calculate recharge areas, then we know how much contamination from the land use gets into it. This is, you folks have read about the PFAS issue, polyfluoroalkyl substances. It's a big issue that we're dealing with. One of the big sources for it is use of firefighting foam that was developed in the 50s to help the Navy deal with flameouts on carriers and that. And then it became used widely throughout the world. And this is a phone booth. Look at that. The concentrations that are not sensitive, the drinking water concentration is 70 parts per trillion. 70 parts per trillion. When we talk about nitrogen concentrations in wells, we're talking about 10 parts per million. So this is much, the sensitivity for human health standard is very low. So it's not only from firefighting foams, and a whole nother talk could be sent on this. If Silent Spring ever comes up to talk here, they've done a lot of groundbreaking work. It's in a lot of our foods. It's in popcorn, microwave popcorn things. It's in stain resistant carpets. We used to be in Gore-Tex. It's ubiquitous. So they've done blood surveys where we all have this PFAS in our blood as well. It was banned in 2001, but this product is still being used, but we still have it in our blood, and we're just on the tip of the iceberg of trying to deal with this problem. So how does ponds deal with this? Well, here's a little Flint Rock pond here. It's Mary Dunn Pond. These are the down gradient wells that have been impacted. And this is the groundwater flow. So here's the groundwater flow lines again that come in. They wrap around Mary Dunn Pond. The wells are getting their water. This is the PFAS plume that is heading down gradient. And Mary Dunn Well was taking all this in and basically distributing it through to the Hyannis water system. So people were drinking this for years. It was recently, in 2015, they put carbon treatment on it when it became apparent, when the level of knowledge finally caught up with us to say, hey, we got a big problem here. So carbon treatment was put on these wells. But what else is going on here is, it's like, here's Mary Dunn Pond here. Here's some of the concentrations that we're seeing. We're seeing concentrations over 100,000 on the site, but further down gradient, there are 25. And this is coming up into Mary Dunn Pond. We've got 82 parts per trillion. The level standard is 70, as I said, and that's discharging back down. And there's a whole nother set of wells down gradient. So this is the next thing that needs to be studied, is what's happening to this down gradient. But the ponds play a major role in this, and even more so. I wouldn't say even more so, but in the MMR again. Here's our favorite little ponds, Ashumet and Johns Pond. We have these various different sources of PFAS coming through these ponds, and so they come from the source into the one lake, and it comes back out. And down gradient, there's been public water supply well that was shut down, community water supply well that's been shut down, and several private wells. And this stuff is called the forever chemical. It doesn't go away. It doesn't attenuate. It sticks in the soils and it dissolves in the groundwater. So the source areas stay as sources for a long time, for decades, and we really don't know how to clean this up yet. And the ponds are kind of, well, they're taking the water in, but then they're distributing it throughout this whole down gradient area. So this might be a little plume that comes into it, contaminates the whole pond, and then the whole pond is a source. I want to just go back to the ice cap and go back to our carbon emissions and climate change and global warming And this is the ice cap. We saw the big Laurentide ice cap. This is Baffin Island. I think we're down here someplace. But since 1979, the ice cap has receded. I think we're putting over, I don't know, 360 megatons of carbon or something into the atmosphere. It's contributing to ocean acidification and also sea level rise. And some of the sea level rise predictions are anywhere from 2 to 6 feet by 2100. And so we were curious about that, and we worked with the USGS and APCC, and they did a study on this. I'm getting towards the end. This is it. Here's another one of those hydrographs. The water tables that we've been measuring, this one we've been measuring since the 50s. And if we look at this hydrograph over a period of time, this is in Truro, there's an incremental increase over this period of time, about a tenth of an inch a year. Well, it turns out the long-term tidal range recorder in Boston, going back to 1920, also shows this level of increase in Boston of the ocean. So we're actually seeing this in this particular well, is this increase, this overall increase of the water table. And that makes sense when you think about this water table lens. It's fresh water, it's floating on the salt water, and as the salt water comes up, the water table will go up. And this is kind of what we see here. This is the lens of fresh water. Here's the salt water. Here's the zone of transition. Here's a stream. Let's call it a pond for today. Septic systems and that. And the sea level. And when sea level goes up about this much, that brings the aquifer lens up. That brings the water table up. That brings the stream up. That could potentially inundate septic systems. So this is one of the things that we're looking at. And it's interesting the role that ponds play in this. So they did this groundwater model, and this is the result of the groundwater model. And this is for the most conservative sea level rise. This is for 6 feet of sea level rise. If it rose 6 feet, that we would see increases of our water table of 2.5 feet through here. In Eastham, let's go up here. We're seeing potential increases of 4 feet, as predicted as the model says, with a sea level rise of 6 feet projected as the upper range. But some of the interesting things is around Brewster, the ponds here, around the Upper Cape, is that the water table isn't changing that much. These are there's not much change at all, so several tenths of a foot. And why is that? Well, anywhere where these ponds daylight and they have an outlet, the outlet is acting as a drain for the aquifer. So although the aquifer is coming up all around it, these pond systems act more and more as drains, and that will keep this the water table from rising that critically around these ponds. So that's kind of interesting, that if you were thinking you had a house around a pond and you were worried about sea level rise inland, and would you be affected by it? That's one of the pragmatic things to take home points of this. But this is, I guess we showed that there was a 5%, if you look at areas that are less than 5 feet to the water table over the Cape, that's about, call it 8% of the area. Under a sea level rise scenario of 6 feet, the area of 5 foot would increase to about 12%. So there's an incremental increase, and it's more acute around some of these near coastal areas. But for the most part, they're not anticipating any harm for water supply wells, or the overall general aquifer health. So that's my talk today, is talk about ponds, the way they work, and some of the project that I have been involved with, and where ponds played a big role, and just a different perspective, a different story than the issue of phosphorus loading and dealing with your single pond as the sensitive receptor that you need to do something with. And the rest of your talk that Jim and the group has put together, we'll discuss that. But these ponds have a much greater role as well within the aquifer. So thank you. Yes, sir.
You may have covered this and I didn't get it, but with regard to the outflow from the ponds, how much of the organic material goes into that outflow?
Not much. Not much. No, it would be, but mostly, the water, the organic materials pretty much stays, in the bottom, and then if you have algae, and if you're throughout the water column, then you can expect some to leave by an outlet if there is one, but it wouldn't be significant enough to change the condition of the pond.
If some of these ponds were created like 15,000 years ago, wouldn't the amount of sediment and what he's talking about have been built up? So if we're looking at 15,000 years of buildup, is it really a lot in the ponds? And does it ever go away? Or does it calcify or something like that?
Yeah, it just turns into a more condensed organic ooze that gets very condensed, and it's not very thick after all. I mean, it depends on the type of pond that you have. Some of the shallow ponds can fill up. Like if we think about some of the more recent pond, like Shankpainter Pond up in Provincetown, that's kind of been filled in by actually plant matter. So it's kind of this quaking bog situation. So that's taking eutrophication to the upper limit. But for the most part, as I understand it, the organic matter pretty much it does. I don't want to say disintegrate, but it consolidates over a period.
Ponds could have a lifespan, is what you're saying?
Yeah, there's a natural progression of pond life. If you take from one extreme to the next, and if you go into a eutrophic situation, and then the eutrophic situation gives rise to much more and more and more organic matter, that finally, we're talking, thousands of years could change it. So I don't think we're not going to see that process in our lifetime. But as a geologist, looking back over 4.2 billion years, or within our glacial period here of 50,000 years, you could see some things like that happen. Was there a question in the back?
It was fascinating to hear about the nitrogen attenuation ability of the ponds, and kind of encouraging, I guess, to know that something good is going on in the world. But is there any evidence, or have you studied this, the treating of the ponds that we're doing with alum, excuse me, for phosphorus? Is that having any effect on the nitrogen attenuation ability?
Yeah, that's an interesting question. I don't think it does, because the alum treatments that I'm familiar with, they're targeting the organic matter in the deeper sections of the ponds. So they're not putting this alum everywhere over the pond, but they're focusing in on the deeper sections. And a lot of that exchange of the groundwater that I was showing actually does happen around the margins. the upper parts of the pond. So where that groundwater flow comes in through that organic matter, or through the light organic matter, it's called the light, and then it thickens at the bottom, that geochemical zone is what does the attenuation, or the bulk of it. Jim?
There are years when we have more or less ice on the ponds, like this past winter, there wasn't much. Does that, the lack of that, I'm sorry, we see more or less ice in different years on the ponds. Does the amount of ice cover affect the health of the ponds?
Yeah, that's, I can't imagine how it might play a role, to tell you the truth. I mean, I do ice skate, so I like to pond skate, so I still do it. Not this year. We did go out, and the first guy broke through, and so I said I wasn't skating that day. But otherwise, I think the ice it wouldn't prevent anything in particular from happening. So I can't think of it. As opposed to the ice on the marshes that we see that lift up great portions of the marsh and things like that. That's kind of more I don't know, drastic kind of actions that they have out on the marsh. But yeah, I don't think so. And I missed the ice this year. And when we did sampling of sediment on Flint Rock Pond next to the Fire Training Academy, when we first found out about this contamination, I was able to go out on the ice and, like an ice fisherman, put a hole through and put my instruments down through the ice and get very good organic sediments. So I think we're lucky that we have ponds that freeze over that we can take advantage of and go ice fishing and ice skating, and it's wonderful to see.
When and how did marine life get introduced into these ponds?
Well, they would only get introduced, the marine life introduced the ponds, only into the coastal saltwater ponds. So like Salt Pond is a saltwater pond. So when sea level rose, that would have brought in that all those plant and fauna into the pond. But the freshwater ponds, we're not really seeing marine life. We don't see marine life in the freshwater ponds. They're fresh, and they were made 12,000 years ago, and they just filled up with fresh water. And so there's been no intersection with salt water.
What about the life that's there, the fish?
It's the biology of how these things progress and how they become populated with different animal life, whether through birds, other critters carrying them. It's fascinating. It really is.
Good question for our next speaker.
Oh, that's right.
Next week and you'll get the answer.
Yeah. Yes, ma'am.
Where could we see a map that's detailed enough to show all these 23 ponds, including the vernal ponds of Eastham?
Oh, there's a lot of different opportunities. I think, I know the Cape Cod Commission has a number of maps and websites that you can go to look at the ponds. And I think, I haven't followed it, but on the town website, if you have had the pond studies done, I believe they post them on the website. So you can go to the town and look for the studies that were done by what are they called? Ecologic Associates, and plus Cape Cod Commission did several as well. So I think one of the things over my period of time that I'm really happy with is the development of the web and the ability to access that kind of information. Because before, everybody used to call me up on a dial phone and where is this information? Now it's on the web, and I'm happy that it is.
are on the Cape?
994 freshwater ponds. Yeah, and about half of those are less than an acre. So they'd be, kind of small ponds, vernal pools, things like that. But there's, you do? Oh, good. Well, it's been counted. Yes, sir?
You showed a bar graph of community involvement and data collection for ponds on the Cape.
Yes.
Is there a place where that data is publicly available, or rolled up and aggregated versions of that data is available to anybody who wants to find it?
I'm glad you asked. One of the things, if I was still working for the Cape Cod Commission, I'd be telling you about everything that they're doing. And one of the things they're doing is they got a big grant for data management. Water quality data management is one of the big recommendations out of the 208 plan, and we tried for years to get a sizable amount of funding for it. So together with APCC and other organizations, we got a big chunk of money from EPA for data management, and we're putting that information together now. And some of it, some of the preliminary information is available on the Cape Cod Commission website. APCC is getting involved with it. I think Brian Horsley is talking to you in one of the future sessions, and they'll be putting together what we want to do is the mine the data, compile it, massage it, and make it accessible to the public. So when people are taking their pond samples, that they don't have to wait 5 years to figure out what happened or what the data means or that, but that the data would be accessible and interpreted as well. So it's a good question. Thanks for asking. Yes, sir?
Yes.
Oh, I think, well, last question.
As far as alum treatments of ponds on the Cape,
Yeah.
how many have been done actually treated in the last 10 years?
Ah, geez, I think it's I don't know, it's over a handful. I don't know if it's 10, but it's somewhere in there. And one of the first ones they did was Hamlin Pond years ago, and it was mixed success. And it had an issue where they didn't do it right. It was the first one. They had a bit of a fish kill. The conservation agent was so upset. We were glad he came into work the next day. But since then, there's been a number of alum treatments. Long Pond was one of the second ones in Brewster, huge one, huge project. And then, of course, you've had one here in Eastham, Shumet Pond, Stillwater Pond, Schoolhouse Pond. So there's been a number of them, and they have a good track record, as well as Cliff Pond in Nickerson State Park. A huge pond. I never thought that would have a problem. We camped there all the time with the kids and all that, and I could not believe the algae blooms and that they had actually had to close Cliff Pond down for swimming. So they did the alum treatment, and it's had good success, and so people that come there can enjoy it again. Thank you.
So just on future events here, I know we have 7 in total. I'm not going to go into that detail. The next talk is Sophia Fox, an aquatic ecologist with the Nashville Seashore, coming to talk about mallards, mollusks, and different things. But I did want to bring your attention because of the questions. Liz Moran, who is our consulting limnologist, and the vocabulary word of the day is limnologist, an expert in lakes and ponds and such, will be coming with the data because she was in charge of all the data analysis of the ponds here, and we'll talk about her recommendations for any treatment that we might want to pursue here in town. So do keep all those in mind, and thank you very much. Oh, Karen is holding up. We have a brochure that covers all the different talks in the series. So thanks very much for coming.